Hey, my name is Nick Valesky, and I'm with the Utah State University Extension's Integrated Pest Management Program. So it's August right now, and I'm out here at a commercial farm at one of our trial sites, looking at the effectiveness of trap crops. So trap crops is growing a target crop next to your main crop that is more appealing to certain pests. Trap cropping is a form of cultural control within integrated pest management that's not widely yet used here in Utah. When used correctly, trap cropping can be a sustainable and beneficial form of pest control. In this specific trial, we're looking at the effectiveness of sunflowers as a trap crop for our commercial tomato production to deter stink bugs away from causing any economic damage to our tomatoes. Similar studies from Penn State University and Florida A&M University showed that sunflowers were attractive to stink bugs and other Hemeroptera species and reduced the marketable damage to Solanaceae crops. There are several types of trap cropping which are characterized by the type of plant, where the plants are grown within the farm, and when they are planted. Let me tell you about the different methods of trap cropping. A traditional and proven effective plant is planted around or within the cash crop that is more attractive to a target pest as either a food source or for reproduction. Our trial with the sunflowers and tomatoes is an example of conventional trap cropping, as we're providing a more desirable crop to deter the desired pest away from our cash crop. Dead-end trap cropping. Plants that are attractive to a target pest but on which offspring will not survive. Dead-end trap cropping serves as a sink and prevents the movement of the target pest to a cash crop later in the season. Dead-end trap crops are planted in field borders or edges where they intercept insect pests. An example of dead-end trap cropping includes the use of yellow rocket mustard plants to attract the diamondback moths to lay their eggs on them instead of the cabbage. Upon hatching, the larvae of the diamondback moth will fail to establish and survive on the yellow rocket mustards. Genetically engineered trap cropping. Plants may be genetically engineered to act as a trap crop. Prevention of insect vector diseases is one example, where the trap crop is capable of harboring a certain virus, but its insect vector cannot acquire it from the plant. In this example, the trap crop helps reduce the insect vectored pathogens as opposed to the insect itself. Genetically modified potatoes that express the proteins from Bacillus thuringiensis, BT, will be toxic to the Colorado potato beetle larvae when they consume the foliage. Growers may choose to plant the GM potatoes at the edges and grow non-GMO potatoes as the cash crop in the center. Perimeter trap cropping. Trap crops that are planted around the border of the main crop. A success story of this includes the use of hot cherry peppers to attract the pepper maggots away from the desired bell peppers. Sequential trap cropping. Trap crops that are planted either later or earlier than the main crop to increase the attractiveness to insect pests during certain times of the season. An example of this includes growing the early season potatoes that will be larger and more attractive to Colorado potato beetles, protecting the younger, smaller potatoes. Multiple trap cropping. Multiple trap cropping. Planting several trap crop species to manage several pests, or controlling a target pest by combining plants whose growth stages enhance attractiveness season long. An example includes corn and potato plants combined as a trap crop to control wireworm populations in a sweet potato field. Push-pull trap cropping. A combination system where a trap crop is planted around the perimeter of a crop to attract the target insect pest, the pole, and a different plant is intercrop to repel or push the insect away from the cash crop. In Africa, a push-pull strategy uses Sudan grass as a trap crop planted around the main crop and a molasses grass planted within the field as a repellent intercrop. Biological control assisted trap cropping. Trap crops that are planted within and around the crop that enhance populations of natural enemies that can help suppress multiple pests. For example, a sorghum trap crop used to manage cotton bollworm also increases rates of parasitism from various parasitic wasps. Finally, semiochemical assisted trap cropping. The use of either manually hanging insect semiochemicals, such as pheromone lures, on a perimeter planting, or using genetically modified plants that emit semiochemical lures to attract the target pest. One of the most successful examples of this is the use of pheromone-baited fly traps hung on perimeter trees acting as trap crops have been suggested for fruit fly management in papaya orchards. So there are several factors to consider when using trap crops. The first is if the life stage of the insect you're targeting will be able to be controlled by the stage of the trap crop being grown. Another factor is making sure you have enough trap crops and being sure that they're planted at the right location and the right time of year so they correlate with your cash crop. So there are some limitations to trap cropping. The first one being is that trap crops usually only target one or specific pest. Another one could be that trap crops might end up costing more money than traditional pesticides as they take up more land, water, and labor to use. If you guys have any other questions about trap cropping in Utah vegetable production, feel free to contact me or check out our new fact sheet on trap crops. Be sure to follow USU Extension Utah Pest on Facebook and Instagram for more daily content, and be sure to subscribe to our Utah Pest quarterly newsletter for articles and other information relevant to you.